Don't forget to subscribe and ring that bell.
We're back. 2019, free response question number 4. No calculator. Who cares? Because the AP Calculus AB 2019 exam is ours for the taking. Let's start this. Number 4 reads, a cylindrical barrel with a diameter of 2 feet contains collected rainwater, as shown in the figure, well, to the bottom left. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height of the water in the barrel with respect to time is modeled by dH/dt, which equals -1/10 times the square root of h, where h is measured in feet and t is measured in seconds. The volume V of a cylinder with radius r and height h is V equals pi r squared h. Whew, that was a lot. A says, find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Indicate the units of measure. We need a label because of this right here. We need to indicate the units of measure. Now, the rate of change of the volume. That means we need V prime or dV dt. I'm going to use V prime, okay? I'm going to take the derivative of this right here. So V prime equals, pi is a constant, so I'm going to leave that out. What's left, r squared times h, that's the product rule. It is the first times the derivative of the second. The derivative of h is just h prime plus the second, which is just my h, times the derivative of the first. The derivative of r squared is 2r r prime. This is a related rates problem, okay? Now, let's take a look at this, okay? In order to find v prime, all right, here we go. We need to find this. Every other variable needs to have a number to it, doesn't it? Okay, well, the radius. That's simple. Let's start with the radius. Okay, my diameter is 2, so my radius is 1. So we've got pi times 1 squared times h prime. Okay, h prime or dH dt is given to us right here. So times -1/10 times the square root of h. They want this when the height is 4. So my h is going to be 4 in here. So that's h prime plus my height, which is 4, times 2 times my radius, which is 1. But what is r prime? That's the thing. And just in case you think I forgot, pi gets multiplied times everything in here. Well, I'm going to tell you a little secret about r prime. The radius never changes. There is no rate of change for the radius. It's a constant 1. And the derivative of any constant is 0. So 0 times anything is 0. This is all going to go bye-bye. So, bye-bye. I now have pi, okay, times 1 times the square root of 4 is 2. 2 times -1/10 is -2/10. 1 times anything is itself. So let's reduce that to -1/5 pi, or we can say -pi over 5. Now they want, notice I'm leaving room in this box, they want units of measure. Do not tell me it is feet per, what's that time in seconds? T is modeled where H is in feet and T is measured in seconds. Do not tell me that is feet per second, okay? Because volume is always cubic feet. So we better say cubic feet per second. They'll get you there, okay? They will get you there. When they say indicate units of measure, if you don't put that label, you get points taken off. 4B, when the height of the water is 3 feet, is the rate of change of the height of water with respect to time increasing or decreasing? Okay, so first of all, when the height is 3, let's do this here. When the height is 3, so we know our H is 3. So when the rate is increasing or decreasing, that means we need to take the derivative of the rate. Okay, there's the rate of the height. So we need to find the derivative of dH dt, which means we need, oh, let's go blue. Nah, it's already red. The second derivative of height with respect to time. Okay, which means my negative 1/10 is a constant, so I'm going to leave this out here. Square root of h, that's the same thing as saying h to the 1/2. So my 1/2 is going to come down front. H, and we're going to subtract 1, that'll be negative 1/2. Now, let's just combine that. When I multiply these two, I'm going to have negative 1 over 20. Since this is a negative exponent, that will plop back in the bottom, and that would give me h to the positive 1/2, or square root of h, which will be in the bottom. This is the second derivative. They want this, okay? Oh, by the way, there's something we forgot. This is a related rates problem. What that means is anytime we take the derivative of an h, we got to put times h prime next to it. So now we got to multiply this times h prime. What's h prime? It's this thing right here. Gotta love it, kids. Gotta love it. So times negative 1/10 times the square root of h. All right? We almost forgot that. So let's now start to combine this where we can. Okay, negative 1 times negative 1 is a positive 1 times the square root of h, which is just 1 square root of h. 20 times 10 is 200. That's nice. Times the square root of h. All right, well, this is a 1 in front of the square root of h, and I know these can cancel. So my answer is actually 1 over 200. It's a constant, and that is greater than 0, isn't it? So that tells me this is increasing. Explain your reasoning. 1 over 200 is greater than 0. So, and I'm going to use the words they gave me. The rate of change of the height of water. It says with respect to time. With respect to time. Goodness. Is increasing. Maybe that's overkill, but I'd rather have overkill and be correct than underkill and be roadkill. Remember that, kids. So the good news is there's only an A, B, C. The bad news is C is probably going to be a little bit more algebraic work, but we like doing that stuff because we're good at it. C reads, at time t equals 0, the height is 5. That is a coordinate there. When t is 0, my height is 5. That's like 0, 5. That is a coordinate that they give us. Oh, use separation of variables to find an expression for h in terms of t. Okay, I am going to take this right here and do separable differential equations. And you know what? I don't mind that stuff. I think it's kind of cool and fun. So if I have dh over dt equal to negative 1/10 square root of h, all right? I've got to get my h variable and my dh on one side. So let's multiply this side by 1 over the square root of h times 1 over the square root of h. All right, well now let's get rid of the dt on the left, multiply that by dt, multiply this side by dt, and what I have left is this right here. Okay, let's give ourselves some room. 1 over the square root of h dh equals negative 1/10 dt. Now, I'm going to clean the left side up a little bit. Okay, I'm going to make that square root into an exponent. So I have this. I'm going to make it this. Not only that, I'm going to bring this up and negate the exponent. So I really have h to the negative 1/2. Okay, so I've got h to the negative 1/2 dh equals negative 1/10. What is going on, Lenovo? dt. Yeah, you can tell I'm not at work, but I'm at home, kids. Let's integrate now. Integrate. Integrate. This is going to be a great integration because I add 1 to my exponent. So I'm going to add 1. So I'll go from negative 1/2 to positive 1/2. And then I divide by that 1/2. I hope you know that dividing by a half is the same thing as multiplying by the reciprocal. In this case, it's like multiplying times 2 plus some constant. We're going to call that C1. How come? Because we're really going to have two constants here. Whenever I integrate a constant here, I have negative 1 over 10, and I just bring that variable back in, t. So for the sake of ease, I'm just going to multiply them together and just call that negative t over 10 plus, here's that second constant I was talking about. All right, the first thing we need to do, okay, we gotta get h alone. The first thing we do is I'm going to subtract a constant from both sides. Boom. This goes away, and I've got 2h to the 1/2 equals negative t over 10 plus, if I add two constants, it just gives me another constant. I don't have to put a little sub 1 or sub 2 because now we only have one constant. All right, well, I suppose at this point, if I wanted to, I can solve for a c here before I do anything else. Do you remember way back at the beginning, they gave me this, when t is 0, h is 5. We're now going to use this to solve for c. So when h is 5, remember, anything to the 1/2 is like square root, equals t is 0. 0 of anything goes bye-bye. So 2 radical 5, that's what my c is. We're going to put that right here. And then we're going to solve for h and get our equation, okay? So I've got 2 times the square root of h, which is h to the 1/2, equals negative t over 10 plus, now this was c, but c is now 2 square root of 5. All right? Okay, this is literally 2 steps and we're done. So first thing is I'm going to divide everything by 2 or multiply by 1/2. It doesn't matter what we do, it's the same thing. Okay, so now we have the square root of h equals, that's negative t over 10 times 1/2 is negative t over 20, plus these 2's cancel, and we just have square root of 5. All right, and last but not least, we need to get rid of that square root, so why don't we just square both sides? They want h of t. They want stinking h of t. Let's given stinking h of t. Just leave it like this. Don't try and square it. Don't be a hero. Save that for Mr. Visca. We're done. You're welcome. And you know what? You're smart too. I'll see you for free response question number 5.
Don't forget to subscribe and ring that bell.